Our next speaker is John Bradshaw, who is Technical Director for Environment and Safety for the World Shipping Council. He is a maritime regulatory specialist and marine engineer with a broad range of senior level experience with maritime engineering, technical and policy matters, including representing the shipping industry at the IMO. John is going to speak on black carbon mitigation, IMO progress and abatement potential. Over to you, John.
Thank you, and firstly, thank you for inviting me to speak at the event. That's very much appreciated. I'll go straight into it. So I'm gonna talk a little bit about black carbon tonight. Hopefully my presentation will be complementary to everybody else's. Certainly, based on the very good presentations, I do feel that we are all speaking very much from the same place. So I won't dwell on some of the stuff that's already been covered extremely well. So as we've heard, black carbon is a species of particulate matter, PM, with negative impacts on climate, local air quality and public health, and all three of those things are important. And as we've heard, IMO started work on this at MEPC 62 in 2011, so it's been quite a long road at IMO, really. Current work is focused on developing recommendatory guidance to reduce emissions. But as I said, I should also acknowledge that this is part of a pathway to mandatory measures, and that we're also working on monitoring and reporting protocol. I was sort of, the purpose of my presentation is to address regulatory and policy issues. But because of the nature of black carbon, I'm gonna cover some technical issues, and apologies if this gets a little bit boring or dry. But because of the nature of black carbon, it is important to consider certain technical aspects. So the first thing is, what is black carbon? And IMO agreed to do the Bondettal definition, which I've reprinted here. That's a lot of words, so what I'll do is I'll go directly on to the next slide, because what does the Bondettal definition say? And really, I think what we can summarise it as is that black carbon is a species of particulate matter that's light absorbing, refractory, insoluble, and that insolubility includes organic solvents such as methanol and acetone, and it's small. And the reason I'm bringing this question up is because it's quite important, because the control measures are very significantly influenced by the physical nature of black carbon. For example, if we consider wet scrubbing, the fact that it's insoluble has implications for the design of a scrubber. They have to be designed for dry phase operation. And that obviously presents the whole issue of wash water discharge and management, which I won't touch on tonight, but whether that's acceptable is another question entirely. It's purely a technical observation on the design of scrubbers. So in terms of how we make BC, I mean, obviously it would be better if we didn't make black carbon. That would avoid the problem at source. But although black carbon is a species of particulate matter, it's important to say that not all particulate matter is black carbon. Not all particulates meet the Bondettal definition. And some of the things that influence the production of black carbon, the engine operating cycle, the engine design, and the load is really critical as an influencing factor. The engine condition, a well-maintained, well-operated engine will have superior emissions performance to a purely maintained engine that isn't optimally operated. And both the fuel type and the fuel composition, so we've already heard the sensitivity of black carbon to fuel type, heavy oil, gas oil, stroke distillates, natural gas, plus those fuels that are going to be entering the industry in the years ahead. And also the fuel composition within those groups, and I'm thinking here of aromatic content. Aromaticity is variable within fuels of the same group. So some gas oils are aromatic, some gas oils are paraffinic. So as already stated, black carbon, we could eliminate it completely by just not combusting carbon-based fuels. And I think that's where the industry really needs to go as part of the wider greenhouse gas debate. We could reduce it by combusting fuels that are associated with lower emissions of black carbon, and using alternative energy sources like wind assistance, for example. By reducing the amount of fuel used, we would reduce the amount of black carbon. And then we have things like managing the engine load optimization, engine condition. And we have after-treatment options. I've already mentioned scrubbing, but maybe a more promising technology is diesel particulate filters, DPF. However, at the moment, current DPF technology does need automotive quality fuel, which is significantly different to marine distillates. However, that's not to say that DPF technology couldn't be developed to operate on marine fuels. And as some of you know, IMO is already working on allowing the industry to use diesels with a lower flush point. So I've identified a few discussion points here, and again, apologies if this is a little bit dry, but it is quite important in the context of discussing control measures. So IMO's identified 3 ways of measuring black carbon: the filter smoke number, light-induced incandescence, and photoacoustic spectroscopy PUS. All of them have good correlation and all of them are effective. We could accept any of them. But there's no agreed limit, emission limit volume, and there's no existing control regulation. As I say, the ultimate solution is to switch to fuels that aren't associated with black carbon, but that's going to need time. So we need to consider what we can do in the interim as the industry makes that much more fundamental switch. So some of the control measures, as we've discussed, are fuel switching, distillates, synthetic fuels, LNG, methanol, and ultimately carbon-free fuels. We could develop an engine test and certification scheme, and that would be equivalent to what we already do with nitrogen oxide emissions. We can optimize engine load, and all of the measured data agrees that BC emissions are highly sensitive to engine load. We could revise fuel standards to include aromaticity. It seems that controlling aromaticity can have a very positive effect. And we can look at exhaust gas after treatment, and DPF would be one of those. There's also proposals for things like electrostatic precipitators, as well as scrubbing. But depending on which way we go, if we were to go down the route of engine certification and after treatment, we would almost certainly need to agree emission limit thresholds and a metrology standard so that we would be able to do verification. An alternative would be to work on the basis of agreeing mandatory measures that don't meet that measurement standard and emission limit values, but based on correlation. So we also have this discussion of mandatory versus recommendatory. And I think, well, everybody would agree that mandatory measures are more effective. but we have to be cognizant of where we are, and we need time to agree this. And one thing that's absolutely critical to understand, that after MEPC agrees a mandatory measure, an amendment to the convention, it has to be adopted at the following meeting. Then we have the entry into force procedure. So we're looking at 2 to 2.5 years from agreement until entry into force. And that's after agreement. So recommendatory measures are less onerous, less demanding, but they are something we can agree quickly. And something to say is, by itself, amending ISO 8217, the International Fuel Standard, to address aromaticity, that's not a regulatory measure. Although clearly the revised fuel standard can be referenced by a regulatory measure. Given where we are in time, we think that the current path to agree recommendatory guidance guidelines as part of a pathway to a mandatory measure is the most appropriate way forward, because we need to make progress. And we anticipate that the end rate, the guidance, will be something equivalent to a black carbon stamp. So this is, I know I'm dwelling on this time question, but it is quite important. And the reason it's important is because if we want mandatory measures, IMO as an organisation has to reach an agreement on what to do. We're looking realistically at 4 or 5 years from now until we can get a mandatory measure into force. That means the organisation has to make its mind up and move towards a mandatory measure if we're going to do this. As WSC, we are very open-minded. All that we would ask is that measures are technically sound and effective. And it will be linked to the wider mission of IMO to reach zero near 2050. Just a quick word, we do, while we are very open-minded, we do urge regulatory alignment. So if we go for an engine test regime to align engine test cycles with the NOx technical code definition, metrology standards are critical, and to be cognizant of other work such as the prohibition of HFO in the Arctic, existing work on NOx emissions certification, etc. So this is my final slide. We think the recommendatory guidelines, what we are sort of looking at as a BC-SEMP, it's a good short-term way forward. The longer-term solution is going to be linked to the wider work of IMO to reach zero emissions as part of the 2023 strategy. As WSC, we do support further work, including development of potential mandatory measures. We are very supportive of reducing the environmental impact of shipping. And that further work should pay attention to other outputs such as GHG midterm measures. As I say, I've returned to this question about time, and given the amount of where we are and what we need to do, we do need to be cognizant and make that decision on what we can achieve in the next 4 to 5 years. And if we want a mandatory measure, we just need to make that decision and get on with it. And that's the end of my presentation.